The chain rule is the derivative rule used to take the derivative of a composition of functions. Here we have f of u of x is a composition of functions. U of x is that inside function. I usually think of u of x as the, quote, ugly function that we wish wasn't quite so ugly. And so to complete the derivative of this composition of functions, what we end up doing is we take the derivative of the outside function, so we see that f prime part. But notice what's inside here is still the u of x, the ugly function, not the derivative of it, but just the ugly function. It stays in there. But then what we end up doing is this chain rule where we pull out the derivative of the ugly function, and it ends up being multiplied by the other part of the derivative. And so we can see perhaps a first example here is this f of x equals 1 over the square root of x squared plus 1. So to begin, we need to use a little bit of algebra to rewrite this. So the first thing we could do is rewrite the square root as the power 1/2. Now, perhaps you're thinking some sort of power rule because we see that power of 1/2, but the problem is it's also within a fraction. So we'd end up having to combine some other sort of rule like the quotient rule with it if we were going to do it this way. But we can be smart because the 1 that's on the top is a very simple thing, and so we could rewrite this by using the exponent rule where if you bring the factor from the bottom up to the top, the exponent, which was positive in the bottom, becomes negative on the top. And so we're really rewriting that function as x squared plus 1 to the negative 1/2. Notice all that I've done here is algebra. I haven't taken any derivatives at all yet. But I'm prepared and ready. And we see here that this u of x is the inside part here, the ugly part that we wish wasn't quite so ugly, because if this were just x to the negative 1/2, we could use the simple power rule, but it's not just x to the negative 1/2, it's some other uglier part, the x squared plus 1 raised to the negative 1/2. And so when we use the chain rule to complete the derivative, we're ready to start taking the derivative now, so we write f prime of x. Our outside function is really the negative 1/2 power function. So we're looking at something u raised to the negative 1/2 power. And so to take that derivative, we would use the kind of an extended power rule. We bring the power down, so we have the negative 1/2 power. And then we have what is in parentheses from the function, that ugly part, stays in the parentheses. And we drop the power by 1. So we have the negative 1/2, and we subtract 1, and I'm going to strategically write it as 2 over 2. So we're going to subtract 2 over 2, just so that I've already gotten the common denominator. At this point, we're not quite finished. We've got the chain part left to do, because that part there is u of x, and we've got to pull out the derivative of u of x. So I'm going to write it as d dx of the u of x, which is x squared plus 1, just so that you see what we're doing here. So now as we clean this derivative up, we see negative 1/2 times x squared plus 1. That whole factor is raised to the negative 1/2 minus 2/2 would be negative 3/2. And then this derivative of the x squared plus 1 is a simple derivative. We have the derivative of the term x squared, which is a power rule. That gives us 2x. And then using the sum rule, we can just add the derivative of 1. Well, the derivative of 1 is 0 because 1's a constant. And so that 2x is the derivative of x squared plus 1. So now we still can do a bit of cleaning up. As we are combining terms, we notice we have, well, not combining terms, as we are doing the arithmetic and the algebra, we notice we have negative 1/2 times this factor that has a power with it times the 2x. And all of these things are multiplied, so we can reorder them and we can regroup them in any way we want. And so to me, I see the negative 1/2 times 2x. I would see the 2 that's on the bottom here and the 2 here canceling each other out, leaving me with a negative x. And then we have the factor x squared plus 1 raised to the negative 3/2 power. And that would be our answer for the derivative.